Hi, hello, and welcome to Catalyze Center for Learning, and I'm here to give you a demo on refraction of light. Here I show you the PPT related to the refraction of light through a lens. We know the light travels through a transparent medium and it gets refracted through it. When it happens to fall on any mirror or a polished surface, they get reflected back. That is, the bouncing back of light happens when it happens to hit a mirror or a polished surface. The refraction happens through a transparent medium. Either it could be an air, water medium, or a glass. Here we are going to discuss about how the refraction happens through the lenses. What is a lens? A lens is a transparent refracting medium which is bounded by two curved surfaces which are generally spherical. So we have two types of lenses. One is a convex, another one is a concave lens. Convex lens is also called as a converging lens, whereas the concave lens, we call it as a diverging lens. And here I show you the shape of the lenses. The convex lens, the shape of the convex lens shown here, it is thicker at the middle and thinner at the periphery. Whereas over here in a concave, the lens is thicker at the periphery and thinner at the middle. Here I show you the technical terms related to the lenses. First we go with the optic center. Optic center is mentioned with the letter O. It just suits for both the convex lenses as well as the concave lenses, which is the midpoint at the center of the lens where the light rays, when enters through the optic center, they just goes without any deflection. And the next is the principal axis. The principal axis is a straight line which passes through the optic center. It is being shown by the line P1, P2 over here. Next is the center of curvature. We know that the lens are the two curved surfaces which are trimmed to form the curved surface on either side of the lenses, and the distance from the center of the circle to the surface of the lens, we call it as center of curvature, and the distance between them, we call it as the radius of curvature. And here comes the definitions of the technical terms which is related to a lens. First, we have the center of curvature. The point in the center of the sphere from which the mirror or lens have sliced is known as the center of curvature, and we denote the center of curvature by the letter C. Radius of curvature is the spherical lens has a vertex which is located at the optic axis. That is the distance from the vertex to the center of curvature. The distance between them will give you the radius of curvature. And the principal axis is the line passing through the center of the lens or a spherical mirror, and the optic center is the point on the optic axis of the lens, and the principal foci is the point where the image gets focused into. So both the concave and the convex lens, they get their image focused at the focal point, and we call that as a principal foci. Here comes the ray diagram of the convex lenses. We know the convex lens is also called as a converging lens. The picture over here shows the ray diagram of a convex lens. We can able to see a parallel beam of rays passing through the convex lenses. As soon as they pass through the convex lens, they get refracted. The lens that allows the light rays to pass through them, and after refraction, they get converged, or all the rays they get together and meet at a particular point, and we call that particular point as a focal point where the light rays they get completely focused into. All the parallel rays which is passing through the convex lens, they get converged, and a line which is passing through the center, that is the optic center of the lens, they just comes out without any deviation. So the straight line which is passing through at the center, they comes out without any deviation. All the other rays which are parallel to the principal axis, they get converged as soon as they come out of the convex lenses. So we call the convex lens as a converging lens, as it converges or collects all the beam of light which enters into and just forms an image at the focal point. And next we discuss about the ray diagram of a concave lens. Here it is shown that all the three lines are the parallel beam of light which has happened to incident on the concave lenses. We know, as if we have discussed previously in the convex lens, the straight line which is passing through the center of the concave as well as the and the image obtained by the concave lens is by tracing the path of the diverged beam, and they meet on the same side of the object. So if we trace the diverged path of the refracted light through a concave lens, they meet at a particular point on the same side of the object and they get focused onto it, and the image is formed on the same side of the object for the concave lenses. And the next comes the construction of a ray diagram. So when the light rays are passed through the concave as well as the convex lenses, the ray diagram plays an important role in defining the shape and size of the image, or the nature of the image which has been formed by the concave as well as the convex lens. Here comes the three rules for the construction of a ray diagram. First, the ray which is passing through the optic center, they emerges out without any deviation. They passes through undeviated when it enters into the lens through the optic center. The second one, the light rays which is traveling parallel to the principal axis, they get focused at the focal point after it gets refracted through the lenses. The third one, the ray which has been passing through the focal point, after refraction it emerges out parallel to the principal axis. So these are the three main rules for the construction of a ray diagram for both the convex as well as the concave lenses. And next, it's about the types of images which is formed by the lenses. So we get two types of images. One is a real image, another one is a virtual image. The real image is formed by the convex lenses, whereas the virtual image is formed by the concave. Real image is being formed by the intersection of rays. Intersection of the rays in the sense when the rays they get converged when it passes through the convex lenses. They meet at the focal point and the real image is formed by the convex lens. So it is inverted with respect to the object and it can be obtained on the screen, whereas the image is being obtained on the opposite side of the object. So we call it as a real image, whereas the virtual image which is being formed on the same side of the object, we call it as a virtual image. And this virtual image is being the one which appears to meet, that is the retracing path of the diverged ray from the concave lenses will give you the virtual image, and it is erect to the with respect to the object and it cannot be obtained on the screens. Yeah, and here we come to the end of the lesson, the refraction of lens. Now I have shown you the types of lenses and how the image is formed on two types of lenses along with their ray diagram construction. Thanks for watching. Have a nice day.